I'm Anil Kumar. Welcome to my series on quadratic relations. We'll now review factoring techniques which we have learned. Here are 4 questions for you. You can pause the video, copy these questions, solve them, and then look into my solution. Question number 1 is to factor the trinomials and a binomial, which is difference of square. Question number 2 is a thinking question. Find the values of k if 4x squared plus kx plus 9 is a perfect square. Question number 3. Find the value of k if 9x squared minus 42x plus k is a perfect square. So we have changed the position of k from being a coefficient of x to being a constant. So that is a change in question number 2 and 3. Question number 4 is a square with side lengths of x minus 1 is removed from a square with side length of 2x plus 1. Find the area of the remaining portion in factored form. So these are the 4 questions for you. You can solve these and then look into my suggestions. Now let us try to solve them one by one. Question number 1. Factor each of the following. We have 3x squared minus 3x minus 90. As you can see, in this particular trinomial, 3 is a common factor. So we can factor out 3, getting 6 is x squared minus x minus 90 divided by 3, which is 30. Now this is the trinomial where the leading coefficient is 1. So we are looking for product of minus 30 and sum of minus 1, right? So we are looking for product of minus 30 and sum of minus 1. The two numbers which can work out is minus 6 and 5. So the bigger number has to be negative, right? So using minus 6 and 5, we could write this as 3 times x minus 6 times x plus 5, correct? So that is how you could factor it. Now the second one here is 49x squared plus 14x plus 1. It is a perfect square. You could write 49 as 7 squares. We'll rewrite this as 7x whole square plus, now 1 is 1 square, right? So the center term here is twice 1 times 7x. That gives you 14x. So I could write this in factored form as 7x plus 1 whole square, correct? The next one is kind of difference of squares. 80 squared minus 50b squared, you could first factor out 2. So if you do that, you get 4a squared minus 25b squared. Now 4 is square of 2 and 25 square of 5. So let me rewrite this as 2a whole square minus 5b whole square, which can now be written in factored form as 2 times 2a plus 5b times 2a minus 5b, right? So we have used difference of square. So what you will notice here that we have used group factoring, perfect square concept, difference of square concept. Now here we have a leading coefficient which is not 1 but 6, right? More than 1. Let us see how to factor this one. Let us do it in a different page. So here is your question number 1D. We have 6x cubed minus 36x minus 13x squared. The first step is you should rewrite this, right? Write it in order. 6x cubed minus 13x squared minus 63x. As you notice, x is a common factor. So we could write this as x times 6x squared minus 13x minus 63. Now we are looking for numbers whose product is 6 times 63. 6 times minus 63, right? So it's negative. And whose sum is minus 13. Now how do we get this kind of a combination? Now that's a difficult thing since we are now working with very big numbers. So the idea here is to factor them individually. So 6 is 2 times 3, 63 is 7 times 9, 9 could be written as 3 times 3, correct? So we got prime factors of these numbers. When you multiply them, you'll definitely get 6 times 63. We need sum of negative 13. That means bigger number should be negative. So we have to make combination of these prime numbers so that we get minus 13 as the sum. How could you do it? Well, let's try. So if you take up 7 times 3, which is 21 times 2, which is 42, take away 9, it doesn't work, right? But if you take up these 3 3's, which is 27, and the remaining 7 and 2, which is 14, then it works, because 27, if I use as negative and take positive 14, we do get minus 13. You get an idea, right? So that helps. So the technique of factoring the numbers and then getting the right solution is very handy, especially when you're working with big numbers. So let's continue with our steps. So the steps involved are, we'll split the center number, which is the coefficient of x, in two parts. One as minus 27x, the other one as plus 14. Right? And then we'll do group factoring. So if you combine the two groups, then what do you notice? 6x squared and 27x, we have 3x common. So we get 2x minus 9. And here we can take 7 as a common factor. So we get plus 7, we get 2x minus 9. Now 2x minus 9 is a common factor. So we can write this as 2x minus 9 times 3x plus 7. Is that clear? So that is how you could factor the given trinomial. Perfect. So I hope the steps are clear, and I hope you appreciate how we have used prime factorization to get our numbers, right? Question number 2. Find the values of k if 4x squared plus kx plus 9 is a perfect square. Let us see how to solve this kind of question. We are given the expression 4x squared plus kx plus 9. Since we need to make it a perfect square, I could write this as 2x whole square plus 9 is 3 square, right? So the center term should be 2 times 3 times 2x. That is to say that the center term should be what? 2 times 3 is 6, 6 times 2 is 12, x plus 3 squared. So by comparing, what do we get? We get the value of k as 12, and therefore k is equal to 12. Right? So this is one way of doing it. So we can now compare the value of k, which is the coefficient of x, and get our answer. Now, if I use k as 12, in that case, I could write this expression as 2x plus 3 whole square, right? So in that case, what I get here is 4x squared plus 12x plus 9. Now, could you use k as minus 12? Let's try. So let k equals to minus 12. Well, in that case, the center term becomes negative, so I could have written this as 2x minus 3 whole square. We'll actually get 4x squared minus 12x plus 9. So you can see from here that for the center term, it could be both positive and negative, right? So remember this part. So the answer is that k equals to plus or minus 12, right? The reason is, when we're talking about perfect squares, then a plus b whole square is equal to a square plus 2ab plus b square. But this is also a perfect square if I make it negative, right? So a minus b will give you minus 2ab. So in such cases, you should expect two answers, right? So note, expect two answers. That justifies the value. Instead of value, we're writing values, right? Okay, so let's continue. Take up question number 3. Now in question number 3, we need to find the value of k if 9x squared minus 12x plus k is a perfect square. Now this time we have removed k and put it on as a constant. So let's rewrite this. So we're given the expression 9x squared minus 42x plus k. Now 9 is 3 square, right? So we could write this as 3 squared. And k could be written as square root of k whole square. So this center term should be 2 times square root of k times 3x. So if you compare now these two equations, I mean the expressions, then you can write the value of k by comparing these. So what you get here is that 42 should be equal to minus 2 square root k times 3, right? Correct? Rather plus 2, right? Since this is negative here, both are negative, they get cancelled out. So from here we can find the value of k. So it becomes 42 divided by 2 times 3, which is 6, should be equal to square root of k. Now 42 divided by 6 is 7. So 7 is square root of k. So what should be k equal to? So that gives you the value of k as 7 squared or 49. Okay? So our answer here is that k is equal to 49. Now this time it is going to be just one value, right? Since the third term, the constant, should always be positive. Now here is the last question. It's an application question. A square with side length of x minus 1 is removed from a square with side length of 2x plus 1. Find the area of the remaining portion of in the factored form. So basically we have two squares. So let's say this is the bigger square and we're trying to remove another square from it. Okay, the dimensions are given as 2x plus 1 for the bigger square and x minus 1 for the smaller square, right? We need to find the remaining area. Once you remove the smaller square from the bigger square, that means this is the area which we need to find. How are you going to do it? And that too in factored form. So I'd like you to pause the video, answer this question, and then look into my suggestions, correct? So this is the portion which we are interested in. So the area of remaining portion is what? Is basically difference, right? So the bigger area minus smaller area. That is to say, 2x plus 1 whole square, which is the bigger area, take away x minus 1 whole square. So that is an expression which can help you to solve this question. Now since we need in factored form, here is a trick. So trick is to use a square minus b square. These are squares, right? A square minus b square is a plus b times a minus b, right? So I'll use this. So I could write this as sum of these two. So I could write this as 2x plus 1 plus x minus 1 times difference of these two. That is 2x plus 1. Difference, I'll just change the sign, minus x plus 1. Does it make sense to you? That means difference of 2, right? Now let's add these terms. We get 2x plus x as 3x. And 1 minus 1 is 0. So that is one factor. The other one is 2x minus x is x. And 1 plus 1 is 2. So that becomes the area of the remaining portion. Is that clear to you? So if you use difference of squares, in that case, it becomes a much simpler question to solve. So I'd like you to appreciate how we have done all these questions, especially the last one. So one way, of course, is to expand, simplify, but that takes a lot of time and you could do errors, right? So note apply difference of squares in such cases, right? One of the examples which you can try now is kind of like this. Let's say we have two circles here, right? So we have one circle, a big circle and a small circle, and we want to find area of the remaining portion, right? Which is this area. Okay, so let's say it's a disk with a hole removed from it, where we know R2, the bigger circle radius, is 2x plus 3, and R1, the radius of, this is R1, this is R2, right, is, let us say, x minus 4. Find the area of the remaining portion, right? So that is a question for you. So that is practice question for you. You can try this out and then write down your answer. As you know, area of a circle is pi r square, right? So you could use area formula pi r square, get the area of the remaining portion. So I hope this exercise helps you to understand how important factoring is and how to do factoring for quadratic functions, quadratic relations. I hope you understand and appreciate it. Feel free to share my videos with your friends, and if you like and subscribe to them, that'd be great. Thanks for watching and all the best.